In this lecture, I'd like to talk to you about the synthesis of triphenylmethanol. So this is a Grignard reaction named after Victor Grignard. He was born in 1871 and came up with this reaction somewhere in the early 1900s and won the Nobel Prize in 1912. And by his death in 1925, 13 years later, over 6,000 references to Grignard reagents. So big deal. It's a reaction that's used very frequently in organic chemistry. So we can see with our Grignard reagent here of all the different types of compounds that we can add it to. So we can add it to water, carbon dioxide, right, aldehydes, ketones, acid chloride, so on and so forth. So it's very versatile. Now, without going into too much details, you can look through this on your own time if you'd like to, but it's believed to go through a free radical type of a reaction. And that's something that I usually just briefly address in lecture, but that I don't typically spend a whole bunch of time talking about as far as the mechanism goes. Now, in our reaction, we're going to be looking at the reaction of phenylmagnesium bromide with benzophenone. And we're going to do this by first synthesizing the Grignard reagent. We do that by adding solid magnesium and bromobenzene in the presence of diethyl ether. This has to be dry, void of water, and we make our Grignard reagent. That Grignard reagent then can be reacted with benzophenone to give us triphenyl methoxide, which is then protonated with an acid workup. Now, a couple things about this experiment. So ether has a very strong smell. It's very flammable, so it must be handled carefully. We're going to work in our fume hoods at all times. And the beginning part of this experiment requires that the ether is anhydrous. So we need to be cautious that we keep our ether corked. Now, the glassware setup for this is somewhat complicated. We're going to have a round bottom flask here connected to something called a Claisen head. And this allows us to have a connection over here to our drying tube, where we're going to put cotton with some calcium chloride into it. And then we're going to have a cap with a septum here where we introduce reagents. And we want to do this so that we limit our exposure down here of our Grignard to the atmosphere where there might be some water. So once we're done doing our synthesis, we're going to have to do a liquid-liquid extraction, and we'll use a sep funnel to that. They're called separatory funnels. So here we have a clamp that's been modified to hold our sep funnel. So the sep funnel has a couple parts. So as you get your sep funnel usually out of your drawer or out of storage, you'll have to make sure that you tighten this cap here and make sure that you get this to be snug again. So they're stored loose so they don't freeze up in place. Now, they're easy to use. What we're going to do is you put in your ether, you're going to do your acid workup, so you'll have two layers. You put a cork on the top of this thing, or you use your little cap that's provided with, and you shake it up and you allow for proper venting, and then you allow the layers to separate. You take the top cap off and then you open the valve to drain out your lower layer. That can be put off to the side and extracted later, depending on what the circumstances call for. So once your product is totally pure and isolated, we'll take melting points. We're going to take an IR of our sample too, and we'll have a provided NMR for you to look at also. So here is our IR from SDBS. You can see here that we have our OH stretch from our alcohol of the triphenylmethanol. And then here is our proton NMR estimation for this. So you can see that you have here your peaks essentially from your benzene rings, and then you have your OH here at about 6.7, right, 6.71.